So I think have a watch, have a look, and then write the notes down as you see fit. So the first one is 7C.1, and this is just a basic probabilistic calculation. We have the expected number of some event is going to equal the number of trials multiplied by the probability. Okay, and you do that in like year 8 when you're doing probability calculations. You know, how many 6s do you expect if you roll a dice 100 times? Well, it's going to be 100 times, what's the probability of a 6? 1 on 6. Okay, so in our circumstance, we have the probability of Matt saving a penalty is 0.62, and he has 37 trials. Okay, so 37 times 0.62, the number of trials times the probability of the event occurring. We've got 22.94. Now the question says, how many times do you expect him to save it? All right, so we do need to round to a whole number because that's a discrete variable, right? We expect 23 saves. Okay, let's move on over here onto 7C.2. And what we're doing in 7C.2 is we're taking the probability distributions. We know how to calculate the median and the mode. Now we're going to calculate the mean. So up here, we're just going to do it manually. In maybe half hour or so, I'll show you how we can use our calculator. So the mean, we also call it E of X. That's the expected value of the distribution, the expected value that the random variable will take. And what it's equal to is the sum of each event multiplied by its probability. That's what that means, okay? So we start with this distribution, and it starts by saying calculate the value of K. Well, we know the probability of all of these events added together has to be 1. So I've just made that statement, 0.4 plus 0.3 plus 2K plus K equals 1, and then I'm solving through for K. All right, something you've done a fair bit in exercise 7B. So we've got K is 0.1. So that's going to change, like we can write these in once we've calculated that. That's 0.1 and that's 0.2. All of the probabilities add up to 1, right? Then for the mean, okay, so this is what 7C.2 introduces to you. The mean, again, I'm using both forms of notation so you're familiar with it. The mean, or the expected value of the random variable, is equal to each event multiplied by its probability added together. So notice I've got 0 times 0.4. That event times that probability plus that event times that probability, 1 times 0.3, plus 2 times 0.2, plus 3 times 0.1, and then you just evaluate it. Okay, now the mean does not need to be a discrete value. Okay, here it just so happens that it's worked out to be a discrete value, but more often than not it won't be, and so you will leave it to 3 significant figures. So that's calculating the mean, and we know mode is the one with the highest probability. There it is. The mode corresponds with the event 0, and the median is the event when the cumulative probability reaches 0.5 or exceeds it, and that occurs here, okay, at x is 1. So 7C.2, the only extension on what you've been doing is calculating the mean, okay, using that formula there. So have a go at that exercise or what we're working on. I'll come around and see how we're all doing.